everyone, I'm John Albert Asuncion, and this is my video presentation about the regenerative cycle. So the problem number one is there are received 68,000 kg per hour of steam by an ideal regenerative engine having only one heater, of which the heater received 15,400 kg per hour. The condenser receives the remainder of at 0.007 megapascal. If the heater pressure is 0.96 megapascal, find the state quality of the steam A at the heater entrance and B at the condenser entrance. So the problem states that we have an ideal regenerative engine with having only one heater. For A, we need to find the state of the steam at the heater entrance. For the given, we have the following. The initial pressure of heater is equals to 0.96 megapascal. Initial heat received by heater is equals to 15,400 kg per hour. Pressure of condenser is equals to 0.007 megapascal. Steam quality at 0.96 megapascal. S1 is equals to S2 is equals to 6.599 kilojoules per kilogram. So the answer for A is at the heater entrance, the state is steam is saturated. For the solution for number na letter B, at 0.007 megapascal, SF1 is equals to 0.5592, SFG1 is equals to 7.7167, S equals to SF plus XSFG, S2 is equals to SF2 plus XSFG2. So the answer for letter B is X equals to 78.3%. Now let's proceed to number 2. So the problem for number 2 is a turbine with one extraction for regenerative feed water heating receives steam with an enthalpy of 3,373 kilojoules per kilogram and discharges it with an exhaust enthalpy of 2,326 kilojoules per kilogram. The ideal regenerative feed water heater receives 11,338 kg per hour of extracted steam at 345 kPa, whose H is equals to 2,745 kilojoules per kilogram. The feed water or the condensate from the condenser enters the heater with an enthalpy of 140 kilojoules per kilogram and departs saturated at 345 kilopascal. The HF is equals to 582 kilojoules per kilogram. Calculate the turbine output in kilowatts. So the problem consists of a turbine regenerative cycle with one extraction of feed water heating. So there are four states. State 1, H1 is equals to 3,373 kilojoules per kilogram. State 2, H2 is equals to 2,745 kilojoules per kilogram. State 3, H3 is equals to 2,326 kilojoules per kilogram. And state 4, H4 is equals to 140 kilojoules per kilogram. State 1, mass flow rate is equals to M1 is equals to 11,338 times 1 hour over 3,600 seconds is equals to 3.15 kilogram per second. State 2, mass flow rate is equals to M2HS is equals to M1HS plus M2 minus M1 multiplied by H4 So M2 multiplied by 2,745 is equals to 3.15 multiplied by 2,745 plus M2 minus 3.15 multiplied by 140. So the M2 is equals to 18.565 kilogram per second. For the turbine output, M2 multiplied by H1 minus H2 plus M2 minus M1 multiplied by H2 minus H3. So 18.565 multiplied by 3,373 minus 2,745 plus 18.565 minus 3.15 multiplied by 2,745 minus 2,326 will give us the 18,117.705 kilowatts.